lower these down. He was very tall. I'm not. So thank you very much for being here. I was half expecting no one to turn up, so it's really, really good. Thank you very much. So yeah, as I was introduced, my name is James Tindall, and I am the mobile mapping manager for Castle Surveys. My history is everything LiDAR and mobile mapping. So everything on top of a vehicle or removing anything, boat, train, that can capture data at high speeds or slow speeds, doesn't matter, just everything moving. That's me. We have a video here that I think you might not be able to see there, but you probably can. Hopefully getting across the scale of what we're able to capture before I dive into the presentation. So what you're seeing on screen is a digital twin of Spaghetti Junction, captured just shy in 3 hours. And what we're able to do with that, which I'll get onto in more detail soon, is extract all your 2D, 3D information. But not only that, we're able to create a model. So we're able to go as far as BIM and Revit models. And the theme of my talk really is largely about potholes, but the underlying theme is all about doing more with less, getting more, paying less and getting more. And it's only available through using technologies such as mobile mapping systems. Mobile mapping systems have been around, I'd say, maybe 5 years in mainstream survey. So it's very still, I think it really ticks that innovation piece still to this day. So here at Castle Surveys, so we're a multidisciplinary organization based in Ashby. We're a survey company, okay? We are very proud to say that we invest quite heavily in the latest geometric equipment. Not for only our benefit, to make our lives safer, our surveyors' lives safer and quicker, but to offer you a better deliverable, more accurate, more cost-effective, and giving you more layers in terms of what's possible. So instead of paying for a survey to get X, you're able to pay for a survey and get X, Y, and Z. You're able to get so much more for your money. So what you can see there, that's us driving down the road, and there's some example of the technology we have currently on our fleet. So I've been to a few of these organization shows now, third year at Elcrig, and what I'm regularly seeing is the two main issues are budgets, obviously, or lack of, but also a lack of internal collaboration. Everyone's got their own siloed area within their organization and their own budgets and their own boxes to tick. And where we're coming from with mobile mapping is sort of using innovative technologies such as this, getting heads together internally, taking a bit of budget from a town planner, a budget from a highways engineer, a budget from asset manager, commissioning a significantly, really accurate, large-scale survey of your local authority, not just to get your topographical detail, not just to understand how many lampposts you've got and how many potholes and cracks, etc., but to get all of that. Having this data available internally has proven to be extremely valuable to local authorities and other people who have got access to it. So what is mobile mapping? Well, mobile mapping is the geospatial data capture from a usable vehicle, as I said. We're capable of capturing 2 million points per second, capable of penetrating vegetation. So even in those areas that you think wouldn't be appropriate, we can actually survey through vegetation to get detail. We've got a large range of up to 490 meters. So anything that you think is out of reach is no longer out of reach. We can get that. You don't need to commission other surveys to get things in the distance. Where we also stand out is the accuracy that we can achieve. We can achieve relative accuracies within our point cloud of 3 millimeters, which means that the deliverable you're getting, whether it's quite basic or really high end, no matter what it is, you can be sure that the data you're getting is highly accurate every single time, calibrated, proven, the top of the top. We also go as far as bringing in high resolution cameras. So it's not just about 3D information anymore. It's about high resolution imagery as well to back up the information that's coming from the LiDAR. So here's an example of what it looks like. So this is myself surveying in a local seaside town recently. This is how the LiDAR overlays. Okay, so that is consistent of millions and millions and millions of little individual points, each with their own X, Y, Z coordinate. Okay. We have the panoramic image, but then we have the high resolution image. So you can zoom into an asset that you're interested in. Now, this should all be available internally within your local authority. Okay, so if you've commissioned a survey and someone wants, I don't know, the location of that bus stop, or height of that bus stop, any signposts, they have to commission a new survey or send someone out to get that detail. They've got that already in-house. And we can give you a 360-degree high resolution image as well, so nothing will be missed. And what's really crucial in the theme of potholes and cracks is our back-down camera. High-resolution road surface imagery to get that extra detail of your cracks and your potholes spanning the entire width of the carriageway. Now, there are other people in the industry that have access to LiDAR and imagery, but what sets us apart? Well, what sets us apart is the LiDAR element. Of course, we've got the cameras and we can run AI, but we're actually sort of slightly going against the curve. We're quite proud of not using AI. AI is quite subjective to how well something's trained. Okay, how well a pothole is trained. Yeah, it takes thousands of images, it takes a lot of man hours to actually get that trained. When LiDAR is a mathematical certainty with all the information, all the millions and billions of points you're getting. So what sets us slightly apart in terms of the LiDAR is the fact that on your left is you've got typical LiDAR used by some people in the industry, which is very called slammy in its nature, quite low resolution. And you can barely make out the white lines, you can barely make out the curves. What sets us apart is the image on the right, where our LiDAR is the highest grade LiDAR, or one of the highest grade LiDARs on the market today, manufactured by Leica Geosystems, which is the market leader in geomatic technology. And what we can do with that is, as you can see the white lines clearly, see the curves, and even go as far as seeing, you can't see it. Should have thought about this better. There's a manhole there, there's some really good detail. So what are the benefits to you then of having much better LiDAR and the imagery? Well, it's minimizing time on site. Okay, no longer sending people out to do laborious tasks with clipboards and tablets. Maybe having people within your local authority, so for civilians or whatever, asking questions, maybe, worried about what's happening. Driving down fairly discreetly and minimizing time on site is crucial. But what's absolutely the most important thing here is maximizing your budgets. And that's why I think we can, with our technology, have a solution for you. Doing more for less with more data, but not paying through the nose for it. Okay, that's really, really crucial. Through that, embracing innovation. This is a really innovative technology. It's not just about LiDAR and imagery, it's also about adding more sensors to that, whether it's thermal, pollution sensors, can all be loaded onto this vehicle to get more information. And hopefully it's going to encourage internal collaboration. You commission a survey at scale. We can capture an entire authority in a day or two, quite simply. Having that data in-house, like I said, is so invaluable. I guarantee you, people will come to you if you're the admiral owner of that data, asking you for bits of information, or have you got the height of that curve there? Have you got that signpost? What's the condition of this building? It's all digitally recorded and available within your authority. No need to pay them money to get someone to go out and get that information. So in terms of example data, bringing it back to potholes and cracks, with our high resolution LiDAR, it's capturing millions of points. So we're not using imagery. We're having imagery to back up our findings, but because we have so much data on a pothole, we can run automatic algorithms in our software, not AI, scientific mathematical certainty on the depth, the width, the length of our potholes and location. So that means nothing will be missed. So the first stage is taking our LiDAR, taking our process data and colorizing it so it looks familiar to you. As you can see there, trees are green, buildings are building color. We then classify it. And again, it comes back to that internal collaboration. You might not care about the road. You might only care about the trees. Someone else might only care about the lampposts or overhead cables or something like that. When we classify it, it classifies it into multiple classes. So where you've got this really big, maybe intimidating data set, it might be, wow, we can't really deal with it. We don't know what we're looking at. You're going to turn everything off. I just want to see the road and curbs to analyze my road defects. Turn it all off and just deal with that. I only want to see the trees for vegetation encroachment. Turn off everything else, just have the trees, the curbs and the road. It's all there available to you just to turn off very, very simply. And that's all done by us at Castle Surveys. We'll classify it. We will just provide you the output that you've asked for, as well as the data in an easy to view format. But in terms of the road analysis, we'll take that road and we'll remove everything, so it's just leaving the road surface. Then on the right, we'll run a very simple algorithm, in this case based on slope. So your pothole, it slopes down. So we can identify the location and the inclination of that slope and colorize it accordingly. That'll then highlight pothole. Not through training an image to say that's a circular pothole of X depth, which is very difficult to quantify. With AI, we give you mathematical certainty on location, and then we can identify the location of that pothole. So we can identify the location and the inclination of that slope and colorize it accordingly. That'll then highlight pothole. Not through training an image to say that's a circular pothole of X depth, which is very difficult to quantify. With AI, But in this case, there's a pothole there that's 21 millimeters deep, plus or minus 3 millimeters. That's the level of detail we're going to, which means that nothing gets missed. If you have a threshold of the pothole of 4 centimeters, and anything above that is crucial, you know that every pothole that we provide you is above that threshold, which means you're not wasting budget on fixing potholes that aren't, at a critical point, as well as the length and depth. So as I said, just behind me, it says we don't use AI. We're very proud of that. It's a very important aspect of our lives, but it's a bit of a buzzword, maybe a bit overused, and we don't think it's necessary when there's other things available. We can then verify with images. With our panoramic image, we've got a 360-degree view. So there you can see a pothole in the right-hand side of the screen. And then we can further back it up with a high resolution. So with a simple mouse wheel, you can zoom into the asset you're interested in, pothole, post, whatever it might be. There's your high-resolution image of that asset, and you can measure off that. You can do more information with that. And then it's how do I display it? Okay. We can display it in our software that we can give you a link to a UI, so you can click on it, you can identify the location of your potholes, your rutting, your cracks, your IRI, your PCI, whatever it might be. But we're a big fan of asking you as individual authorities, well, how do you want it? Do you want it in QGIS? Do you want it in ArcGIS? Do you want it in Esri? Do you want it in a different platform? How do you want it supplied? It's a very simple process for us to go, right, there's our potholes, you can have them in DWG, shapefile, however it might be. Okay, so we're not about having we can do this, but you've got to adapt to our use cases and learn a new software. We collect the data, we analyze it, we'll give you the data, we'll also supply anything that works for you, because it might be different to a different authority. Okay, so we're very, very adaptable in that way of working. Bringing it back to the theme though of sort of multiple use cases, what else can we do with one part of our mobile mapping system? Well, because our system's measuring over 500,000 points per second, because we're able to capture speeds of 2 miles an hour up to 70 miles an hour on the M25 in the centre of London, on a boat or a train, what else can you do? Obviously, the pothole identification, relatively simple task, often one button click. Crack detection, we can go as far as flood risk assessments. So because we've got a 3D model, we can run analysis on flood and simulations. So if you're an authority that gets regular flooding, we can have that. You can have that as a byproduct of that initial survey, which might be useful internally. Vegetation management, asset management, how many posts, how many signs, how many traffic lights have you got in your authority? Again, very, very simple to extract. Not using AI, but using 3D point cloud. We know the shape of a lamppost, we know the shape of a traffic light. We can just run a very simple extraction and put in a CSV file, shape file, however you want it. Street sign extraction. We can take your street signs and digitally extract all the text. Put it into a CSV or however you need it. Then we've got these other use cases, roughness index and PCI scores. Our software can do all of this. It's just, what do you want? It all comes down to that initial capture at scale. Then there's the sort of sexier things, the fly-throughs, the stuff that look quite nice in marketing, to really show off within your authority what you're capable of. Similar to that Spaghetti Junction video you saw at the start. Anyone from Birmingham City Council here might be looking at that going, wow, I want that, just to show off what we can do to other people. Bins, right for lights, the list goes on and on and on. So hopefully, I'm going to good turn. Yeah. Well, hopefully, just to summarize then, what we're saying is LiDAR is more powerful than image only. Images are great. I can't use both. Okay. Capturing data on the move is incredibly efficient. But why are we commissioning surveys to capture only potholes? And then you're paying for another survey to extract a topographical extraction, or another survey to understand your lampposts and signs. Why aren't we doing this at the start? Getting everything we need to a high degree of detail and having that in-house ready to use throughout the year. Maximizing budgets. And I think I've had lots of conversations today and in the past from people who agree with that. So hopefully you do as well. And we really do believe that large-scale data capture is a must to a local authority. Digital twins are extremely crucial to how we can make data-driven decisions, whether you're a town planner, it's a TRO, a topographical engineer. You will need that 3D information, but you need it to a high degree of accuracy. and we can provide that at a very cost-effective price point. So there's a QR code if you want to scan out our details. We're on stand number 67. If you want to see the system, we've got the system there, the mobile mapping system. We've got data to show you if you want to see it. But hopefully, no one's left, so that's a good sign. Must be right.